Hello, so I'm Harry Bevins. I'm a third year PhD student at Cambridge, and I'm going to talk to you about a Bayesian reanalysis of the SARAS2 data from the epoch of reionization. So this is a global 21 centimeter experiment, or a sky average 21 centimeter experiment. And essentially we have an antenna temperature that looks like this on the left. And we fit this with a foreground model that's based on maximally smooth functions. So it has very smooth properties. And it will essentially reveal any non-smooth structure in the data, like a global 21 centimeter signal or a systematic. And we actually find a systematic in the SARAS data, which you can see in these purple residuals. And we model this as a systematic from the sky, and then separately as a systematic introduced in the radiometer electronics. We also model the global 21 centimeter signal. So we're trying to constrain the parameter space of the global 21 centimeter signal. We have two sets of semi-numerical simulations. The first we could consider a standard astrophysical models with additional Lyman alpha heating and CMB heating. The second is a set of exotic models with an excess radio background that could be used to explain the edges detection. We train neural network emulators on these two sets of simulations with global EMU. We feed all of this modeling into Polychord, and we perform nested sampling to get out 1D and 2D posterior distributions in the astrophysical parameter space. And we actually perform multiple fits with different systematic models and different noise models, and we combine the samples in the astrophysical parameter space weighted by their evidences. And all of this is in a paper in preparation, but just to look briefly over the results. So for the standard astrophysical signals, you can see that our 2D posteriors and our 1D posteriors are very flat. And when we look at the functional posterior shown here in red and compare that to the functional prior shown in blue, we don't see a big significant difference. And that kind of suggests that we're not really constraining the standard astrophysical parameter space at all. Previous analysis of this data set has indicated or ruled out signals that were very deep. But because we have these additional heating mechanisms in our theoretical models, we can't actually reach the depth of those signals. So we wouldn't necessarily expect to rule out the same types of signals in our analysis. But for the exotic models with an excess radio background, we do rule out very deep signals, which again, you can see by comparing the functional posterior and the functional prior. And these deep signals, they correspond to high values of F radio, so the radio production efficiency of high redshift radio galaxies, and low values of FX, the X-ray efficiency, and high values of F star, the star formation efficiency, all in combination. And you can see that in these 2D posteriors where the blue regions show regions of lower probability. And as I said, all of this is going to be in a paper. It's in preparation at the moment. If you have any questions, feel free to email me. My email's at the bottom of these slides. But otherwise, thank you very much for listening.